Okay, we are on 5.4, pH and POH. We're going to skip the warm-up and go straight to the pH scale. You guys have been talking about the pH scale since middle school. You may not have known what it stood for. It stands for potency or power of hydrogen scale. And the pH scale is a logarithmic scale. So we're looking at powers of 10 to quantify the hydronium ion concentration in a solution. So if you're given an acid, you have the hydrogen ion or hydronium ion concentration, you put it here, and you would take the negative log of the concentration. Your log key is on the left-hand side of your calculator. If you're given a concentration with 2 sig figs, for example, and you're taking the negative log of that concentration, when you write the corresponding pH, your textbook likes to tell you to take the number of sig figs and translate that to the number of places past the decimal. So you would go 2 places past the decimal to represent those 2 sig figs. I mean, I loosely follow this. I mostly do this when we're doing the practice problems in the section. But on Canvas, I'll tell you how many sig figs I want. When we measure pH, we often use a pH probe. You probably used a pH probe or a pH meter in biology. And we're going to be doing a lab tomorrow where you're combining an acid and a base, and you have the probe in the acidic solution, and as you add the acid, the pH will change, and you're going to graph that change. If you ever have the base or the acid directly hitting the probe, you'll notice that the pH will spike. It'll either like dive down or it'll come back up. And eventually, as you swirl the solution, it'll even out. Let's take a look at the quick check. If I have an orange juice solution and it's got a hydronium ion concentration of 3.2 times 10 to the negative 4th molarity, how many sig figs is that?
2.
2. So if I have 2 sig figs here, how many places past the decimal should my pH go?
2.
2. So to get the pH, we're going to take the negative log of 3.2 times 10 to the negative 4th. You'll end up with 3.49. Easy enough? Okay. Let's go to question 2 then. During a titration, the pH of a solution decreased quickly by 5 units from 8 to 3 at the equivalence point. Did the hydronium ion concentration increase or decrease, and by how much? Well, if my pH was below 7, a pH that's below 7 is what kind of a solution? Acidic. Acidic. Okay, so if I have an acidic solution, the hydronium ion concentration would be increasing. Okay, by how much? Well, for every pH unit, you are changing by a power of 10. So if I went down by 5, this is really a 10 to the 5th increase in the hydronium ion concentration. Does that make sense?
Mm-hmm.
Okay. So I know you guys have talked about the basics of logs in math, but have you talked about antilogs? No. Okay. So think of the antilog as the inverse of log. So if you have pH equals the negative log of the hydronium ion concentration, this would be the antilog of that equation. So if you're given the pH, you can calculate the hydronium ion concentration. So it would be 10 to the negative pH. Okay? So this is your log expression or your log equation. This is your anti-log equation. Okay. Let's take a look at the next set of practice problems here. many sig figs do I have here?
3.
3. So if I want to write the corresponding pH, I'm going to go 3 places past the decimal, right? So the negative log of 5 times 10 to the negative 5th. This would be 4.301, and there's my 3 decimal places. But what if I'm given the pH instead? I can calculate the concentration of hydronium ions by taking 10 to the negative pH. So since I have 2 decimal places here, that means I would have 2 sig figs in my hydronium ion concentration. So my hydronium ion concentration will be 10 to the negative pH. So 10 to the negative 3.34. And this is 4.6 times 10 to the negative 4th molarity. Can we all do that?
Mm-hmm.
Great. Let's skip 2 and 3. I'm going to expand this P concept to include bases. So what we're going to do is we're going to talk about if I have the hydroxide ion concentration, then I can get something called the POH. So this would be for bases. If I have a base, I would put the hydroxide ion concentration here, take the negative log of it, and get the POH. Well, how does the POH relate to pH? pH plus POH is 14. The pH scale runs from 0 to 14. Okay? How do the hydroxide ion and the hydronium ion concentrations relate to each other? Well, here you can see that hydroxide is on the y-axis, hydronium is on the x-axis, and the hydronium ion concentration versus the hydroxide ion concentration gives you an inverse relationship. So as my hydronium ion concentration is increasing, my hydroxide ion concentration is decreasing. Or as my hydroxide ion concentration increases, my hydronium ion concentration decreases. Okay? If I take the negative log of these concentrations, I get pH and POH. They've plotted pH and POH here. Okay? So here you have pH and POH plotted, and you'll notice we get a linear relationship, but we have a negative slope. pH and POH are summarized here in this table. Since the pH scale runs from 0 to 14, if you have a neutral solution, that means the pH and the POH would both have to be 7. So that means they would equal each other. But if you're acidic, you know, because you learned this in middle school, that the pH is less than 7. So your pH would be less than the POH. And if you are basic, your pH is greater than 7, also learned in middle school, so your pH would be greater than the POH. Everything we just discussed is summarized here. So let me explain this table to you. When you're neutral, your pH and your POH are both 7, and the concentration of hydronium and hydroxide ions would be the same. As I move to the left, I become more acidic, so it would be strongly acidic the closer you are to a pH of 0. If your pH is 0, your POH would have to be 14, so it would have to be much, much greater, right? Because pH plus POH is 14. Your hydronium ion concentration would be 1, and you would have a very small hydroxide ion concentration. Okay? If I go to the right-hand side of this table, you become strongly basic as your pH gets closer to 14. So if your pH is high, your pH is going to be extremely low. Your hydroxide ion concentration will be close to 1. And your hydronium ion concentration will be very small. Okay? Let's use this information and do the practice problems on pH and POH, and then we're done. We're going to do the first row here, and then we will do number 2. This says complete the following table. We're looking at orange juice. If I have a POH of 10.5, how would I get my pH?
Subtract 10.5 from 14.
Good job. So pH plus POH is 14. So pH plus 10.5 is 14. You're going to get 3.5? Okay. So my pH is 3.5. When my pH is less than 7, what kind of solution do I have?
Acidic.
Acidic. Okay. If I want to calculate my hydroxide ion concentration, I just need my POH, because 10 to the negative POH is the hydroxide ion concentration. So 10 to the negative 10.5 is?
3.16.
So 3 times 10 to the negative 11th? I rounded room. So 3 times 10 to the negative 11th is the concentration for the hydroxide ions. If I want hydronium ions, it's 10 to the negative pH. So 10 to the negative
3 times 10 to the negative 4.
3.5. Yeah, so 3 times 10 to the negative 4. Can everybody do that? Okay. Let's go on to number 2.
It's just such a weird combination.
As a solution becomes more acidic, both hydronium ion concentration and POH increase. And both hydroxide ion concentration and pH decrease. B, a basic solution has a POH value that is blank than 7.
Less.
Less. Look at the table on the previous page. Less than 7. And the hydronium ion concentration is,
Less.
it's really, really small, right?
So
it's less than 10 to the negative 7, because it's like 10 to the negative 10th, 11th, 12th, 13th, 14th, okay? C, if the pH of a solution equals 14, the hydroxide ion concentration equals?
1 molarity.
Good job, 1 molarity. Also in the table. D, if the POH of a solution decreases by 5, then the hydronium ion concentration has
Increased by negative. Like that's power of 10.
the POH decreases by 5. So the hydronium ion concentration decreased by a factor of 10 to the 5th. We good?
Would that just